Hello, hello. This is Paul Durkee, and we are going to start working on Solidworks and drawing the part one of the offset boring head. So I have the print up right now. As you can see, it's got a lot going on. We got features coming at it from, well, let's see, we got top, one, side, two, three, four. We have four different we have like about four different sides of features on this. So what we're going to have to do is we're actually going to have to come in and use those four sides as planes. So in Mastercam, this was kind of a complicated process where we had to create new geometry and all that stuff. But since we're now in SolidWorks, it's going to be quite a bit easier because of the whole parametric thing, right? Because we're defining these features as relations to other features. And because of that, we don't really have to create planes. SolidWorks is smart enough to say, all right, we're making this feature on the side of a part, right? So it'll automatically create, basically it automatically creates a plane where that is. So because of that, it kind of simplifies this process. This would be multi-steps in Mastercam, but now we're in SolidWorks, so we can kind of streamline this and get this drawn out faster and more accurately, since we can troubleshoot and check things out. So we're going to switch to Mastercam now, right? So I have my Mastercam. I'm sorry, I have my SolidWorks window open right now, open to the top plane. So what I'm going to do is I'm just going to basically draw a rough shape of my part. So, well, first thing I'm going to do is I'm going to normal to my top plane, right? So I can right click on my top plane, select normal to from that menu, or actually just left click that and go normal to. If I know what view I want to be in, I can also go up top to my view orientation, and this will open up this little cube thing. All right, so when I click on one side of this cube, it's going to orientate so I view it from that side, right? So pretty cool. So how about we do this from a right plane? So I'm going to create a new sketch on my right plane, and all I'm going to do is if I look at my print again, so if I look at my print, right, I can look at that guy and say, all right, well, I have a dovetail with a little rounded slot there. Going back to a dovetail, we got chamfer, but relatively straightforward from the side, right? And that will draw or create the geometry for most of my part. So that's what I'm going to do. That's the side I'm going to start off on. I don't have to. I could start off on any of these sides, but because of the shape of the part and how it looks, I think I'm going to start off with this side. This kind of makes the most logical sense to me. So if I go back to my SolidWorks window, so I'm not going to really worry about making this absolutely perfect, right? So I'm not going to worry about making sure that my dimensions are perfect or anything like that. All I'm going to really do is just kind of get the general outline or general shape of it. And because of this is symmetrical, one of the things I like to do, which is not really required, but doesn't hurt, is to actually put a center line down the middle. So a center line is going to be a dashed line. Another way, the way SolidWorks deals with it is they say that this line is for construction, right? So what that means is if I do an extrusion or if I do any sort of solids or surface creation, it won't use this from the sketch. It won't use this line at all. It'll just ignore it because it's for construction, right? It doesn't really matter. I could give it infinite length, but who wants that? All right, so I'm going to click OK, and now I still have my sketch open, and now I'm just going to basically draw just the general shape of my part, right? So if I have my blueprint open on another page, so I'm going to look at that. I'm just going to start off with this edge, right? Comes down, has a chamfer. We're going to go across. Going to go up. Chamfer is going to be equal. And one of the things you'll notice as you do this is these your angles will typically snap to certain, or your lines will typically snap to certain angles. Obviously, they're going to snap to horizontal or vertical, just like every other program, but they will also typically snap to 145-degree increments along the circle, right? So it'll snap to vertical, horizontal, obviously, but it'll also snap about halfway in between there and display the angle that you're currently drawing this line at. So hopefully for obvious reasons that can be pretty handy as well. So one of the things I kind of forgot my dovetail here, so I'm just going to go ahead and draw that in now. All right, so I got my dovetail. I'm going to go down here. I'm just going to draw just a rough shape, right? It doesn't need to be perfect. This is the beauty of Solidworks. And I'm just going to trim. Oops. I'm just going to trim, power trim. There you go. All right, so obviously, if you look at if we're comparing this between the what I have drawn right now, my print, not even close, right? And that's fine. It doesn't need to be close. Well, it needs to be kind of close, right? But as far as our dimensions go, it doesn't need to be. It can be anything you really want it to be, just as long as it's relatively in the same sort of shape. So if we go back to our SolidWorks, right, and so we know that basically this angle here is going to be 60 degrees, right? So if we use our smart dimension, I can click on that and I can say that's going to be 60 degrees. Right? And then I can click on this side and I can say that side is also going to be 60 degrees. Right? And so now we can see what happens when we kind of draw something in a parametric program and not everything's specified. So what it's doing right now is that I drew this line at an angle, right? If we, if you rewind or whatever, you can look at when I draw this, it's not horizontal. And so it's actually going to try to preserve that same shape as long as it possibly can. So one of the things we can do is we can go through here and kind of edit our geometry to make or change the relation so it's more what we're looking for. So obviously from our print, we want these two lines to be collinear. So if I click on the first one and then hold down control and click on the second one, well, immediately I can see my add relations over here in my properties. So in this case, I want these to be collinear. All right, so collinear just means that if we have two lines that are separated by a gap, those two lines basically are on the same axis, right? So if I click on collinear here, it's going to change my shape again, right? But the big problem here is this top line. So you can see this is still trying to make a line going all the way across. Well, we don't want that line like that. We really want that line to be horizontal. So if I can click on both those lines, and over here I can go to my add relations. Right, so earlier it didn't have the relation of horizontal, but it was trying to maintain roughly the size or shape that it was based on whatever the additional relations I add in there are. So in this case, I want this line to be horizontal, so I'm going to click on horizontal. And automatically we're back kind of a little bit closer to what we're looking for. All right, so pretty straightforward. I'm just going to I'm going to delete. Oops, I'm going to delete these chamfers real quick because really the better way of doing this, because this is both these chamfers are the same size. I'm actually going to use the chamfer tool over here. So my chamfer tool, sketch fillet, sketch chamfer is going to work basically the same way as basically the same way as Mastercam. So we can enter in our distance of that chamfer. We can, make different kinds of chamfers. We're just going to do a standard standard chamfer. And then we're going to click there, and it's going to automatically fill in our chamfer, right? Make it the right size. So, all right, we're good there. All right, so now let's go ahead and add a circle. So the circle for this guy, if we look at our print, give me a second. So if you look at our print, we can see right here, the circle is going to be, looks like the center of the circle is coincident with that, maybe, and tangent with this edge of our line, which works out, yeah, we have a 1/4 inch circle with a 1/8 inch wide slot. So if I go back to Solidworks here, I can go to my circle, and we basically have two different options to make a circle. I can make a center circle where I click first on the center point of this, and then my second click is going to be on the outside, on the circumference of that circle, or I can do a perimeter circle where I just select 3 points that are on the perimeter of that circle. So that's more like a tangent circle, right? So if I'm trying to select multiple points that I want this circle to be tangent to, that's what I would do. Well, if I think back to what this is, the center point of the circle is going to be on this line, and the edge of it's going to be on this line. So a center circles drawing tool is really good. It's going to be perfect. So in that case, I'm just going to go here, and you can see it doesn't matter where I go on this line, because I have this line selected, it's going to use this line as a tangency, right? It's not until I get to another point or get off of that line that it's actually going to create it like a normal circle. But just by putting my cursor on this line, it's inferring that I want to make this line, or I'm sorry, I want to make the circle I want to make the circle tangent. There we go, tangent to this line. Okay, so we go like that, and there we go. And I'm going to go back in with my power trim. I'm just going to trim what I do not want there. And then I'm going to dimension my circle. So it defaults to radius. In this case, because it's a partial circle, so the radius of the circle would be 1/8 of an inch. I'll click OK. All right. And so from here, we basically have the shape of our part. Right? If we go back one more time to this, to our print, right? We basically have the same shape. From here, all we need to do is actually put the rest of our dimensions in there. And so that's what I'll do right now. So in this case, we're just going to use a smart dimension tool, so we can get to that right up there. And from here, let's start with our dovetail. So this dovetail is going to be 1.500 inches, 1.5 inches. All right, so as you can see, pretty off center. We'll fix that later. So when we start doing dimensions, one of the things we will have over here is, again, anytime we have any sort of feature selected, the property manager will open up and have all the all the properties we can adjust for that one feature. So in this case, our feature is a dimension. And so in that dimension, we can change all sorts of stuff. We can change how the leader reacts with this, right? So right now we are up with this 1.5 inch dimension. So if I wanted those arrows on the outside of those extension lines, I could click on that. If I want them on the inside, I could click on that. This is an automatic, so this is kind of like the smart dimension. It'll kind of figure out where it should be based on what's going on. I can change my extension line style, my leader style. I can change all this stuff, right? Then I can also override units. Right? So say I have a part that is in inches and I want to ship this out to China, right? And they want all their dimensions in millimeters, or vice versa. Say we're getting something from Sweden and we want to put it in inches. Well, instead of going in and editing everything, we can actually just override the units. So instead of saying inches, I could say I'm going to override these units to millimeters. and it'll transfer and automatically do my conversion for me. So it's pretty sweet. I don't have to only do this. I can also use dual dimensions. If you go into your first tab here for dual dimensions, that will allow us to basically do the same thing, right? So now we have 38.1 millimeters and 1.5 inches for the width of that slot. So that's pretty nifty. Not incredibly useful, but pretty cool, right? We can do that. It is really useful more for us converting from metric to standard. I used to use this all the time when we did Bodine stuff because everything came from millimeters, but we still kind of like to conserve that on the prints. So I would typically make those in dual dimensions. One of the best things that we can do here, though, is actually, and one of the things that will save us time on the back end when we make prints is using our tolerance and positioning attributes. So right now, this is to a 2 decimal place tolerance. But if we look at our print, right, this guy is going to 2 decimal places plus 1/2 minus 0. So in my mind, anytime I see a dimension like that, I would, since the tolerance is going to 4 decimal places, I would expect the original dimension to go to 4 decimal places. So I'm going to change that. So now we are out to 4 decimal places, right? But what about our tolerance? Well, again, we can add our tolerance here. So the advantage of doing this here is when we go to make a print, we can automatically populate the dimensions on the print. So if we make the dimensions correct here, even correct in so far as how they are toleranced, that can save us some time on the back end. So our basic tolerance is a plus or minus, right? So, you know, no, I'm sorry, that's the basic dimension. Bilateral tolerance is going to be our plus or minus, plus and minus. Or bilateral can be a lot of different things. So bilateral, we can have this as plus 1/2 minus 0. What you'll, at some point in time, I don't think that we have really dealt with them very much, but you will see something like this. So this is 1.5 inches plus 1 thou plus 1/2 thou. Right? Pretty weird. But this is an actual way of dimensioning. So when you have fits, this is a very, very common way of dimensioning things, in fact. So what this is saying is, you know, if you make this part to exactly 1.5 inches, it's going to be too small, right? So you can kind of think about what that means is, well, this is a part that fits together with another part, right? And obviously we want the internal dovetail to be a little big and we want the external dovetail to be a little small from the nominal. Well, this just basically does that. This is exactly what that's saying. When we look at a tolerance and it's a plus 1/2 minus 0, that's kind of telling us the same thing, right? We want to make it just slightly bigger than 1.5 inches. If we make it any smaller than 1.5, it's not going to be big enough. This is basically saying the same thing, but this kind of makes it easier for the engineer because then they don't have to do math on this 1.5 inches. They can just leave it 1.5 inches and say, this is what I intend for this part to do. Maybe my other part is -1 minus 1/2, right? So a little different than what we're used to, but like I said, it's actually a fairly common way. I won't say common, but you know, it's a way of dimensioning you will probably most likely see at some point in time. So even though this says plus minus, these are just maximum minimum values. You can have negatives in here. You can throw a negative in there. It will change how your tolerance is displayed, right? So we can put negative numbers in there if you want to. You can put positive numbers in there. They can both be positive. It doesn't really matter. It will display them, right? So anyway, that's bilateral tolerance. Limits, right? Pretty self-explanatory. Same tolerance. Tolerancing, and as far as how it happens in the property manager doesn't change, but what does change is how it's displayed, and that's it. Still the same tolerance. Symmetric, that's our unilateral tolerance, so that's a plus or minus 1/2, right? Got to do that. Can throw a parentheses if we want. Doesn't really matter. Min or max, right? should be pretty self-explanatory. And then fit. So if we select the fit, we can then kind of select, all right, is this going to be a clearance, transitional press? This is really more used for holes and shafts, stuff like that. And then we can select which kind of fit we're looking for. You know, if it's a G5 on the hole and no match. Didn't like that one. All right, so basically we can go and select different fits. That's not really what we're doing though. Fit with tolerance is going to do the same thing, but now we're throwing in a tolerance there, right? So if I select G5, that's saying our tolerance for 1.5 inches is going to be plus 0.8 plus 0.4. So kind of similar to what we just had, right? If I select G6, it'll change that and so on. So if you're more curious about what this means and how to use these and all that, surprise, surprise, you can check your machinery handbook and it will have all that information in there for you. H5 is pretty close to what we're got. See, so like H4, H5 would basically be the type of fit we're looking for. H5 would be plus 0.4, H6 is plus 0.6. So as you can see, that's basically what we're looking at. But like I said, if you're kind of interested in fits and the engineering behind fits, there's just an enormous amount of information in your machinery handbook. But for this guy, we're just going to do a bilateral because that's what we're looking for, right? So we're going to change that to 1/2. Don't want to give you guys too much room on that. All right, so 1.5 inches there, and then we're going to smart dimension again. So another thing is, like, let's say I have this dimension and I go, oh, wait a minute, I want to change something in that. Another great thing about Solidworks is we can just click on it and immediately we are, as soon as we click on the lines associated with it, our dimension manager, or feature manager, property manager, that's right, will open up on the left. So again, we can go in here and change these values, change to whatever we need, change how many decimal places our tolerance is, and blah, blah, blah. So pretty cool. All right, so I'm just going to keep dimensioning this guy. This guy is going to be 5/16 from top to bottom, 313. So we're good there. Just like Mastercam, get in the habit of saving often. There are some things that I feel like SolidWorks is a little bit more stable, but I am on a laptop computer right now, so I don't really trust it very much. All right, so then the height on this is going to be 1 inch 170. All right, so I changed that, and as you notice, it did not change the position of this. And the reason I didn't is because there was no relation between those two. So what I'm going to do is I'm going to actually backtrack. I'm going to hit Control Z and go back just a step. Right, so I'm going to delete that dimension. And so what I'm going to do here is I'm going to dimension this guy. I'm going to dimension this circle, or that hole, because that is this hole here, right? So we are 300 thou up from the bottom and we're 510 in from the side. So I am going to just dimension that guy and then change my height. You'll kind of see the difference here. So if I smart dimension, I'm going to click somewhere on the perimeter of that circle or circumference of that circle. I'm going to hit 0.3. I'm going to change that position so it just drops right down. All right, I'm going to dimension this from the side, and that's going to be 0.51. All right, and I'm just going to go ahead and dimension the width of it as well. So it's going to be 2.02. Uh-oh. So, as you might notice, now our part's kind of all goofy, right? So what do we do here? Well, we can kind of think about it. So this part's all goofy because we have basically lines that are overlapping each other. But if you remember, all these kind of have a relation to each other right now, right? So we have the width from this point to this point. This is a line that connects this point to this point. So what we can do is we can basically drag this across and kind of get it back in a more realistic position of where we want it, right? So let's just drag it down like that. And as you can see, it's going to keep all my dimensions. Isn't that handy? I'm just going to kind of move them around so it's a little less crazy looking. But as you can see, it's more in line with what I'm looking for. So now if I do dimension the height, right? So that was going to be 1.17. Say 1.17, click OK. And now we look pretty good. All right, so at this point in time, this should be fully dimensioned. This should be fully, if we want to use this as a model to extrude from, well, then we want to be able to do that. So what we're going to do is we're going to create. Basically, what we want to do is we want to be able to make this symmetric, right? It's a symmetric part, and that's what we want to do. Right now, my center line, though, is off center. Well, good news is I can change that. So if I go over down to this line here, right, I can select my midpoint of that line. I can, again, hold down Control and select my center line, which will immediately open up this little menu, which is also over here. Right? I can add my relations. So in this case, I already selected the midpoint of this line, so I don't want to do midpoint, midpoint. So what I want to do is create a coincidence. So I want to create a coincidence so that this line and this center point of this bottom line are occupying the same space, right? So they are coincident. So if I click on coincident, that's going to slide everything over. And so now what I can do is I can actually make things symmetrical. So that is another sketch relation that I can make, right? I can make things symmetrical. So if I click on that point, click on this point, right? And then I'm holding down Control this whole time, and I click on my center line. Well, now in my add relations, I only have two options. I can either make these symmetric, that's what I want to do, or I can fix them. So fix them is going to basically cement these or glue these in place so I can't move them out of the way after the fact, right? So I click symmetric. That's going to make those parts symmetrical, and now I should not be able to drag these, right? If I can drag any of this, I know that this is not fully defined. All right, so I can drag it up or down. And as I drag that up and down, one of the things I notice is that my slot is kind of moving around and being all goofy, right? And if we think about it, well, what did I not do? I didn't dimension the width of that slot. So I know from my print that this is going to be, I know from my print that this is going to be 1/8 of an inch. So I click on one side, click on the other, drag it out, and make it 1/8 of an inch. Bam. So at this point in time, I believe that that is fully done, right? I have my dovetail, I got my slide, I got the hole, that's dimension 375. Well, that's from there to the center line, that should be there anyway. Yeah, I think we are good. So what I'm going to do here is I'm going to actually use this sketch to make an extrusion. So if I turn this around, I can see that this is all one dimensional. So if I click on my sketch, and I don't really actually need to even click on my sketch. If I just go to features, because this sketch is open, it's smart enough to know that that's what I'm talking about. I'm just going to do an extruded boss base, right? So again, in our solids, instead of having a solids tab, this is just called features, but it's the same thing. We're creating solids based off of sketches. So in this case, we're going to do an extrude, and it always defaults to 100 thou, which is, like we're making sheet metal or something. So because of that, be aware of that guy. And let's see, how big is this guy? So that's going to be 2 inches, 220 thou. All right, cool. And so as you might notice, as soon as I click OK or click somewhere else on my screen, the sketch that I used to define that is gone. So one of the things that can happen is you can extrude this, look at it, and go, oh, yeah, I really messed that up, right? So there's maybe a feature that I forgot or whatever. Best part about this is we can still go in and edit this. So if we click on this little arrow next to Boss Extrude, we can click on Sketch, and once we click on the Sketch tab or the Sketch feature in our feature tree, or what's this called? Feature Manager Design Tree. We can actually edit this sketch. We can go back into the sketch. It's going to pretend like I didn't do that extrude. It'll still keep it there, but it's basically going to step back to before I did that extrude, and then I can go in and change anything. And when I click change, I can regenerate that extrusion, and it's going to be exactly the change that I made to it. So pretty snazzy. All right, so for this guy, what else do we have? We still have, well, let's put the chamfers on there. So if we look at our print, right? So we have these 200 thou chamfer in 10 places, right? 10 places. So we're going to chamfer this guy real quick. So let's go like that. All right, so we're going to, up here in our, again, we're in our features ribbon. We're going to go up to fillet, and then underneath that is chamfer, which brings up our chamfer feature manager, whatever. So we're going to put 0.2 for our distance, and we're just going to go around and we're going to select the edges. So I want that edge. I don't want to select sides here because it will try to put a 200 thou chamfer on that line, which it's like putting a chamfer on a chamfer. Yo, dog, I heard you like chamfers. All right, so we're just going to select all the sides. This usually goes quicker on a faster computer. And let's select him. Oops, did I just select that side? No, that was already selected. Okay, so now I click OK, and it's just going to throw a 200 thou chamfer on all those corners. So it looks like I did something wrong, doesn't it? So those are all 200 thou chamfers. Oh, well, there's no chamfer on that side. All right, well, that's a good example. So on the part, I over chamfered this guy. If you look at my part, right, there's no chamfer on this edge. Chamfer comes up into that corner, comes up into that corner, and then there's no chamfer. So yeah, I totally over chamfered this guy. So I will go back to this guy, and same thing. I don't need to start over on this. I don't need to delete this and try again. I can go into this and edit this part, or edit this one feature. So if I right click and go to up top, edit feature, well, now I'm right back in this menu. All right, so I'm going to go through and I'm going to unselect that line, that line, that line, and that line. So I feel like I under chamfered now. Oh, yeah, there we are. All right, so what I need to do is chamfer. If I look at this print, right? So I got my print. Hold on a second. So I have my print. So if you look at the bottom here, right? So this entire side is not chamfered. Basically, we have a chamfer on the top, these front and back edges, and then these corners. So what I can't do is I can't say this is chamfered and chamfer that at the same time. What I have to do is chamfer these 3 sides or 6 sides, because it's on both sides. I have to chamfer this, this, and this, and then in a second chamfer, add this chamfer onto here. And if I go to here, you can probably see that. Right, so in this case, if I try to edit this chamfer and put a chamfer at the bottom here, right, it disappears. So I can't do that. But what I can do is go in and create a chamfer, a second chamfer feature, right, and then I can click on that side. I can click on that side, and that side. Now we're talking. There we go. Okay, so I'm done with chamfers, and if you look at my feature tree, right, or manager tree, feature manager tree, I have 2 different chamfer functions, or chamfer operations, whatever you want to call these. If for some reason I needed to label these so I knew what they were better, I can, right? So I could say chamfer number 1. I'm going to go really outside the box with these, and then I'm just going to call this, instead of chamfer 2, chamfer number 2. I know, I'm a wild man. Right, so pretty straightforward. So from here, we're basically just adding some holes, and I think I'm going to save that for next time, using the hole wizard. So we'll just kind of stop her there, and we will continue this on in another video.